Hello everybody, welcome to the Python course. Today we will see module 11, that is Introduction to Numpy. This module has been divided into two parts. In the first part we will see how we can create arrays using Numpy. Then we will generate an array using the Numpy inbuilt methods. And we will also look upon what are the advantages of using Numpy versus your Python list. How fast is your Numpy array as compared to your list. In the second part of this module, we will look upon various operations that are performed on this Numpy array, and we will look upon the indexing, slicing, and how to iterate through these arrays, right? And also we will see upon the various mathematical and statistical methods that has been provided by Numpy. So overall this is very important topic, and it is basically a library which we gonna study and work upon. So let's start. I have already opened up my Anaconda navigator. Now we'll launch a new notebook and we'll start working in this notebook. Okay, I will go to documents, GitHub projects, then Python trainings, Trunic, and here we have completed till module 10, and now I will create a new module, that is module 11, Numpy. Okay. So in this, as I've already told you, we will see what is Numpy, how we can generate or create an array using Numpy, and then we have some inbuilt methods that we can generate your arrays, and in the last part we will see what are the advantages of using Numpy as compared to your Python list. Okay, so what is Numpy? Numpy stands for numerical Python. It is the fundamental package for numerical computations in Python. Okay, just give the importance to this word numerical computation. Any kind of numerical computation, arithmetic operations we wanted to perform, that we can perform faster via this package. And it supports n-dimensional array objects that can be used for processing multi-dimensional data, and it also supports different data types. So overall, so for any terms of your computing power, so this Numpy package is very much effective. So using this Numpy array or Numpy library, we can perform the following operations, that is mathematical and logical operations on array. We can perform the Fourier transformations, or we wanted to perform our linear algebra operations. That could be performed easily and in a much faster and effective manner by using your Numpy. And we could also perform random number generation, right? So let us try to create an array using our Numpy, right? We all know that we have our list in case of our Python, right? And this list we wanted to convert into our Numpy array, right? So that could be easily converted by using your np.array. From where does this np came? First we need to import the Numpy library, as we have already seen in our modules lecture, right? To import any external library, we need to follow the keyword that is import followed by the name of the library, and we could also support it by using your alias name. So this is basically your nickname or alias name, you can say that, right? We wanted to call numpy, not numpy as np, right? So np.array is the inbuilt function in which we could convert the Python list into your numpy array, right? And when we tried to find the type of this x, it resulted on the class of numpy.nd array. So basically a numpy array is your n-dimensional array, right? And your list in Python, this was a one-dimensional array or one-dimensional list, you can say that, right? Okay, so why it is called an array? Because it consists of a similar data type, right? But in the case of list, you could have your mixed data type, as we have already discussed. So you cannot have your list, right, having your different data types. If you wanted to convert your list into numpy array, that must be of numerical part. That is, either it would be of data type integers or float. You cannot have your strings, booleans, or other than your integer or float, you cannot have your data types. If you wanted, because numpy is pure numerical Python, so it only performs calculation on your numerical part, on your numerical data, which is of integer data type or floating data type, right? If you wanted to convert it, so it will result you in an error, but you can convert only your integers or floating point values. So here it has resulted us in giving us a numpy.n-dimensional array, and if we try to print x, so it seems like similar to our list, but it is not list, it is your numpy.nd array. Okay, so let us try to practice this and see how it works. So first we need to import our numpy, right? So we will simply say import numpy as np. So this module has been imported to us. Then we'll say np.array in this part I pass a list or a list of integers, right? And I take it in a x variable, or I would rather say np underscore array, right? So this is your np underscore array, right? Sorry, np underscore array, and this is your variable, and the variable type would be of nd array. If I wanted to print the type of np underscore array, it will give us the np.n-dimensional array, right? And if I simply print it like this, it will give me the array, right? So it says an array of single dimension, of a one dimension, of a 1D, right? Okay. So this was our 1D array. Now if we wanted to create an n-dimensional array or a 2D array, so we need to pass two-dimensional data or our two-dimensional list, right? So in the example you can see that the data is of two-dimensional, right? So it is having rows and columns. So it is having 4 columns and 2 rows, right? So if I try to convert this list which is of two-dimensional into np array, so we get a similar structure to this. So it is an array which is of shape 2 cross 4. This means 2 rows and 4 columns. Here you can see that we have 2 rows and 4 columns, and the dimension could be checked by using ndim attribute, and it gives you 2. And if you wanted to try to check the shape, you can have .shape attribute. So remember, these are not functions. Don't try to put your parentheses after your attributes. So these are basically your attributes. So it is giving you the dimensions and it is giving you the shape in the form of a tuple. right? So let us try to execute this. Okay, so I have np.array. I try to pass a two-dimensional list. Let us take a different example, right? So this is your np.array, and I try to name it as x equal to, right? Then I print x. So this is 3 cross 3 matrix, right? We have 3 rows and 3 columns, right? If I try to print the dimension of it, I can use your dimension attribute and print end dimension. It is of 2 dimension, right? And if I wanted to print the shape of it, so it will say it is of 3 cross 3 shape. Right? So this is how we have converted your two-dimensional list into your Numpy array, which is of dimension 2, and it is of shape 3 cross 3. We have 3 rows and 3 columns, right? So we have created a n-dimensional array. Now we have some inbuilt functions or inbuilt methods in which we could return your specific n-dimensional arrays, giving you with the field with some integer values or floating point or integer values. So let us try to see the method. That method is numpy.once, right? So the syntax is numpy.once or np.once, and we need to pass it 2 parameters, that is, one is shape and of d type, right? If you don't specify the d type, the by default d type is your floating point values, and shape you need to define it. For example, you need all the elements in your 3 cross 4 array to be ones. That could be done by using your ones, right? So this is your ones, and it has filled all the values by using floating point values, and its shapes is 3 cross 4, that is 3 rows and 4 columns, right? So let us see this. So we have np.once, and suppose I wanted to fill the shape equal to 5 cross 2, right? And the d type is equal to int, right? So right, so this shape is 5 cross 2, right? I could change anything. I could have a 5 cross 3 also. I could have 5 cross 5 also, right? If I don't specify the d type equal to integer, by default it is a floating point value, right? So this is how your np.once work. So next is, if you wanted to generate arrays using zeros, that is, in the previous example all the elements were filled by integer 1, and now we wanted to fill all the values by 0. That we can do it by using your numpy.zeros method, and it takes the 2 arguments as in case of ones also, that is shape and d type. If you don't specify any shape, it will take by default as floating point values, or either you could specify your integer values, right? So this is similar to np.once. This is np.zeros, and we need to specify the shape. Shape, remember, always has to be given in tuple, right? If I don't give any shape, that is 5 cross 1, this is one dimensional. So let us try to look this. So this is your single dimension, which consists of 5 entries, right? If I specify 5 cross 1, that is a 2 dimensional. Now you can see that there are 2 brackets, so this is 2 dimensional, right? So if I wanted to check the type, or I wanted to check dot n dimensional, so it gives you 2 dimension, right? and if I don't specify anything, and then if I check and dim, so it is one dimension, right? So you can see the difference. Okay, so this is how we could convert any of your list data type into ones, or we can create your zeros with some specified shape, that is 5x2, 7x2, 3x2, 1x5, any shape you wanted to create with, right? So these are the two methods. One is np.ones, another is np.zeros, right? Okay, then we need to convert or cast an array from one data type to another. How we can do it? In Python there is a type method, right, in which we could check the data type of a particular object, and the typecasting in Python, we need to specify assignment operator. After assignment operator, we need to specify the type, that is the data type which we need to convert it, and followed by the variable name, right? But in this case we need to specify the as type. For example, this is your NP array, right, and the by default your data type of this array is int64, right? Int64 is nothing but your 64 bits, right? And you need to convert your array.as type, right, of your np.float. So in this array we wanted to convert the data type integer to np.float 64, right? So let us try to do this. So let's create an array equal to np.array, and here we have 1, 2, 3, 4 and 5, right? So I print this array. So the data type of this array is int64, as you can see that. Now I wanted to change into the float underscore array equal to array dot as type, and here I would specify np dot float, right? You can either specify 16, 32, 64, anything, right? Now you can see that the data type has been changed to float, and if I wanted to print the data type, what does it hold? So I can do it by using your d type. Now you can see that the float underscore array data type has been changed to float 64. First it was having your array that is int 64, right? So this is how you can do the typecasting in case of your Numpy array. Then we could have operation between arrays and scalars, right? So here one thing to remember and one thing to note, right? How would you do your array operations or your list operations? So let us try to first understand that one. Then we'll compare your Numpy arrays. So let us try to do an activity. So this is your list 1 and this is your list 2, right? So what I wanted to do is I wanted to add each and every element, and the resultant list 3 would have 3, 5, 7 and 9. I wanted to perform operations that is element wise, right? So what I wanted to do is I wanted to add the individual elements and get the sum of the elements in the resultant list 3. If I do list 1 plus list 2, what will happen? This list 2 will get added into list 1, right? But it will not give the output as desired, which is written as list 3, right? So it simply does this operation. List operations in Python will not give you element wise, operation or will not give you element wise computation. It will simply add the elements or concatenate the list 1 to list 2, right? But if you convert your list 1 into a numpy array and do the element addition operation, right? So the addition would be your element wise, right? So here I am trying to do is list 1 array 1 plus array 2, right? So what will happen? I am getting your individual element wise operation. So 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 4 is 7, and 4 plus 5 is 9, right? So this we can achieve by using your numpy arrays, not your Python list. So this one thing we remember, or one thing we understood by this activity, is that all the elements in your numpy array could be changed by a scalar operation or by some value we could change it, right? We could either multiply a similar number so that all the elements get multiplied by same number. We could change the value, right? So these are your arithmetic operations between equal size arrays, that is being element wise. For example, here is your two-dimensional array, right? If we try to multiply that array, the elements get multiplied. So 1 into 1 is 1, 2 into 2 is 2, 4, 3 into 3 is 9. Similarly, if I minus the subtraction operation in case of your array, so all the elements would be element wise subtracted. And if you try this operation, same operation, by using a scalar value, so that scalar value will get multiplied or divided by the individual elements. Here in this case it gives you the power, right? So here you have divided 1 by array, right? So this is how your operation between your arrays and scalars happen in case of your numpy array, right? For example, this is array underscore 1, and if I try to add 2, right? So now at every position 2 gets added. So 1, 2, 3, 4, 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5, and 4 plus 2 is 6, right? Similarly, if I do a multiplication, every element gets multiplied. Also I can do a array wise operation also, array 1 multiplied by array 1 also, so it will give you your square, right? And also I could do this operations, array 1 into array 2. So 1 into 2 is 2, 2 into 3 is 6, 3 into 4 is 12, 4 5 are 20, right? So this kind of operations will occur, right? Okay, so next is we could generate your arrays using your linspace, right? So it returns equally spaced numbers within the given range based on some sample number, right? For example, we wanted to create an array which will automatically give us the equally spaced numbers within the given range, right? We specify the start range, stop range, and number of samples, also specify the data type, right? So this can be done by using your linspace array, linspace function. For example, we wanted to generate an array B starting from first and stopping at 5, but between 1 and 5 we need to generate 10 samples, right? So starting from 1 and starting from 5 we need to generate 10 samples which are equally spaced, right? So this means starting from 1 and starting from ending at 5 we have generated 10 equal samples, and these samples have been incremented by some value. So you can see that here 0.4 is your incremental value. So 1 plus 0.4 is 1.4, and plus 0.4 is 1.8, plus 0.4 is 2.3, right? So this keeps on incrementing and it has given us equally spaced 10 samples, right? Okay, so this we can do it np dot linspace, right? If you don't know the syntax, or you wanted to know what parameters are there in this function, then press question mark and then space, so it will give you the signature. So it will say start, stop, number of samples, right? So if you don't specify number of samples, so by default it gives you 50 samples, right? So endpoint true, red step and d type. So this I will discuss, right? So first is your starting from 2 and ending at, let's say, 10, right? So number of samples I wanted to generate is I guess 7, right? And d type equal to np dot float 64, right? So let us try to run it. So it has generated 2 to 10 and 7 samples, 1 2 3 4 5 6 and 7. If I specify here, let's say 10, so it will generate 10 samples, right? So now 10 samples have been generated, right? Also I could specify the shape also if I wanted to, 5x2, so let me check whether the shape is there or not. No, shape is not there. Okay, so basically we wanted to generate a single dimensional array, so this we have generated, and then we could reshape this value, so that we will cover in the next part. Okay, so this is basically generating a single dimensional array with some values, right? So we have got 10 values. Now this 10 values could be arranged in a 5x2, 2x5, 1x10 and 10x1, right? So that you could do it by using your reshape method, that we'll discuss in the next part of this series, right? So let us try to concentrate here only. So in this linspace we are trying to generate equally spaced samples starting from a particular range and ending at a particular range, right? And the number of samples have been also been specified, right? Okay, now we are specifying the red step. So what does red step true gives us? It will return the samples as well as the step value. For example, here in this previous example I have told you that it increase your next sample by 0.4. Now in the red step, if you do it as true, so it will give you the value also, that incremental value, right? So it is trying to give us the incremental value also, right? If you put red step equal to true. So here in this case, if I put red step equal to true, so now here you can see that the incremental value is 0.88, right? Okay. Now the next function is your arrange function. So what does arrange does? It returns equally spaced numbers within the given range based on the step size. So it is similar to your linspace, right? So here we wanted to generate an array with a start 1 and a stop 10 by specifying your step, right? So here we could generate equally spaced integer values, but in the linspace you were generating your floating point values. This is the difference between your linspace and arrange, right? So now here in this case, what I can do is I can do a range, right? And I wanted to specify 2 to 10. So here it has generated samples ranging from 2 up till 10, but 10 is not included, right? If I wanted to give a step size that is 2, it will be generated, alternate values would be generated because it has given a step size of 2, right? Now the next function is your random.rand. It returns an array of given shape filled with random values. Okay, so you are working with your problem statement and you want to have your random values inside your array, and then you could reshape it by any size what you want. First you generate it. You want to generate 5 random values in the form of NP array that you can generate it, and then after that you can convert into 2-dimensional, right? Okay, so this is how you could convert your np dot random dot rand sorry, right? So it has generated 10 different values randomly. So if I try to execute this statement again, it will generate 10 different values again, right? Okay. So we here in this random.rand we can specify the rows and the columns also, right? For example, we want to generate a random values with 5 rows and 2 columns. We could specify the shape inside it, right? So here if we see the documentation, so it's a random values in a given shape, right? So here if you see, you can see the example here which is given. So it is trying to generate a 3x2 matrix with the random generated values. So here also we could specify 3x2 and it will generate a random values, right? And the shape of 3x2. We have the 3 rows and 2 columns, right? So this is how your random.rand works. Then the next function is your log space. It returns equally spaced numbers based on log scale, logarithmic scale. You need to specify the start value, stop, end of sequence, then number of samples to be generated. By default it takes 50 samples, right? Endpoint we need to specify if true, right? Then the stop is also included. The stop value is also included. If you don't specify it true, then stop is not included, right? Then we need to specify the base of the log space, which is default 10, then d type, right? So let us try to do it. np.log space 1 to 10, number of samples generated is 5 and endpoint is true, right? np.log space 2 to 10, right? So between 2 to 10, so these are the log values which has been generated, and we haven't specified the number of samples. So let us try. There are 50 samples by default. If I try to define your samples, that is 10, so by default it gets 10 samples, right? So this is how your log space works. So far what we have done is we have tried to introduce the array generation by using different functions. First was the linspace, which gives you equally spaced numbers, that is the floating point value. Second was the arrange, which gives you the integer values. Third, you need to have random generated values, right? So these are not equally spaced, these are random generated values. Then you could have your log space to the base 10 or any base you want, particularly depending upon your problem statement. So that way you could generate your log space values, right, based on some scale. Okay, now we'll cover the next part of this. What are the advantages of using Numpy? So So far I have told you that Numpy supports vectorized operations, that you can do the element wise operations on your Numpy arrays, right? So this is the major advantage of doing your Numpy, right? And array operations are carried out in C, and hence the universal function in Numpy are faster than operations which are carried out in Python list. Here one of the major advantages of Numpy is that we have the Numpy arrays, only the integer or the floating point values are there, right? So when you try to compile this code and the interpreter try to interpret it, so we have to deal with only two types of data types, that is your floating point and the integers. But in the Python list, when you are trying to do the similar operation, so it first need to identify what kind of data type is there, because in your Python list it is of mixed data type, right? So you need to, so the compiler or the interpreter needs to first understand, or first needs to check what type of data type is your Python list holding, and based on that data type, what are the operations that can be performed on this data type, that has to be done. For example, we cannot perform arithmetic operations on your strings, right? So that is why Numpy is your faster as compared to your list, right? Then we can practically prove it why Numpy is faster than your Python data types or Python list. So there is a module in Python that is time at IT. It can be used to measure the execution time of your code. You write your code and you wanted to check how much time does this code took to execute it. That could be done by using your time at module. And we could compare the processing speed of an list and an array using this same operation. Likewise, we do an addition operation to our list, and the addition operation is done similar to your array, Numpy array, right? That we could check the performance and check the how much execution time both the operations took. So let us create a list. So there we have created a list, and we are trying to calculate the sum of this list. So this is a range of 1000 elements which are present in our list, and we are trying to calculate the sum. So it says 17.7 nanoseconds. Right? But if you create a Numpy array and do the similar operation on your np.sum, right? So it takes 5.41 microseconds. That is microsecond, sorry, not nanosecond, microsecond, right? So we can say that our arrays works faster when compared to our list, right? So let us try to do this and check by ourselves. So first we need to import the timeIt module, right? Then we create our list by using our range function, right? So here the type of range is range, so I need to convert into a list. Okay, right? So the list is our range, and if I try to print the list, so this contains 1000 elements, right? Okay, so let us try to calculate the sum of your list, elements inside your list. Let us wait for some seconds, since this operation is going on and it has been carried out in your 6.83 microseconds, right? So it was 17.7, and here it took 6.83, right? So let us try to convert it in your numpy.array and your here right, so now you can see that it took us faster, right? So it was 6.83 and it took us 6.19 microseconds, right? So here if I don't convert in this part and try to run directly, so it will take much longer time. You can check by yourself, right? So 6.64 it has taken. Right, so now you can see that. So this is your range function. In range function I have put and tried to calculate the sum of your x. So it has taken 19.3 microseconds, right? Both ways I showed you, whether you are working with your list part or whether you are working with your any of your other data type, right? So that yield us, both the operations gave us much longer duration, right? But in the case of your numpy array and performing your numpy.sum, so it gave us 6.19 microseconds, right? So this is how you can see that array works faster when compared to your list, right? So the next advantage of using numpy is your storage space. So now we will compare the list x and array y from the previous example to find the memory used at the runtime. So we have a function called getSizeOf which returns the size of the object in bytes. So let us try to visualize it and understand it. How much memory does both the data types is holding, right? So we'll get system.getSize of the object, and item size in the numpy array will return the size of one element of a numpy array, right? So first we'll get the length of x and we'll get the get size of 1 into your length, right? So first we'll check this. So for that we need to import your sys dot get size of 1 into length of x. So 28,000 bytes of memory it took of your list, right? And the size of an array can be found by multiplying the size of the individual element with the numbers of elements in the array, right? So that we can see it by using y dot item size into y dot item into y dot size, sorry. $8,000 bytes. So now you can see that as compared to your list with your numpy, it took nearly 3 times smaller, right? More than 3 times, like 3.2, 3.3, you can say that, right? So this is how your numpy is faster in terms of your computation also and in terms of your storage also. So it takes less space. So that is why numpy is always preferred with your Python when doing your numerical computations. Look, Python is faster for development. So you can easily write your code and you can easily start working with your Python language. So it is very effective when it comes in terms of your writing your code and executing it, because it is very development is very fast in case of your Python language. But when it comes in terms of computation, your complexity, that time it gets lower, right? So that is why we prefer, in case of numerical computations, your numpy, right? Okay, so in this part we have done how we can create array, and we could generate different arrays using different functions, inbuilt functions that is being provided by your numpy, that is linspace, arrange, once, 0, and then we have seen random.rand, then log space. Then in the last part we have seen why we are using numpy as compared to your Python list, and we also saw how it is being in terms of your storage and your memory, and in terms of your faster execution, why numpy is better than your Python list. Okay, so the rest part will cover in the next module. In this module only. The next part of the remaining lecture will be covered the next video tutorial. So stay tuned for that. So thank you guys. Thanks for watching.